Hello everyone, this is Pure Mathematics, Chapter 1, Section 1.8, Linear Functions and their Graphs. So let us look at the definition of linear function. A function f from R to R is called a linear function if f is defined by fx is equal to ax plus b, where a and b are any real numbers and a not equal 0. In the previous chapters we have seen any function of this form fx is equal to ax plus b, where the power of x is 1, is called a linear function and the coefficient of x is not equal to 0. That is, here the coefficient of x is a and a should not be equal to 0. So any equation of this form fx is equal to ax plus b is called a linear function. For example, we have some linear functions here. The function f from R to R defined by fx is equal to 3x plus 12. It is a linear function where the x power is 1 and coefficient of x is 3. That means in place of a, 3 is taken, a is 3 here and b is 12. So with a is 3 and b is 12, we are getting this linear function fx is 3x plus 12. Similarly, if we choose another two different values for a and b, we will get another linear function. If we look at this one, second example, gx is equal to x minus 0.1. So x coefficient is 1. That means a is taken as 1 and b is taken as minus 0.2. So this is one linear function with a is 1 and b is minus 0.2. And third example, hx is equal to 1 minus 3 by 2x. This is also a linear function where a is minus 3 by 2. X coefficient is a. So a is minus 3 by 2 and b is the constant. Here b is 1. So we can choose any constants a and b and you can write in the form ax plus b. Then it will be a linear function with the condition that a should not be 0. The coefficient of x should not be 0. Any real but not 0. That is the condition on a. For example, you can take fx is 2x minus 1. This is also a linear function where x coefficient is 2. So in place of a, the value is taken as 2 and b value is here minus 1. So the general form of the linear function is fx is equal to ax plus b. Always the power of x should be 1. That indicates it is a linear. In the linear function, x power is always 1. And in the graph, it represents a straight line. Always this linear function represents a straight line. Now let us look at the definition. The graph of a linear function f is the straight line passing through the 2 points a0 and 0b, where a is the x-intercept of f and b is the y-intercept of f. So for any linear function like this, before we have seen ax plus b, then it passes through, it is always a straight line, it passes through 2 points. What are those? a0 and 0b. a0 when x-intercept is a and 0b when y-intercept is b. So if we find the intercepts x-intercept and y-intercept, then you can draw a line passing through these 2 points a0 and 0b. That will be the linear function. And we have some remarks here. The graph of any linear function f exactly one x-intercept and one y-intercept. So if we take a straight line, how many intercepts it will have? Only one intercept x-intercept and only one y-intercept. That means it intersects y-axis at exactly 1 point and it intersects x-axis exactly 1 point. And the domain and range of linear function is always set of real numbers. So in the domain you can take any real number. That is, the domain is R, and the range also will be set of all real numbers. And the graph of the linear function fx is equal to x. So this is an identity function fx is x, which is also a linear because it is of the form ax plus b, where a is 1 and b is 0. If we compare this fx is x, fx is equal to x with the standard linear equation, a will be equal to 1, b equal to 0, and this is a linear function and this represents a line always pass through the point 0 0 origin, because if we put x is 0, y also will be 0. Therefore this line is a straight line passing through the origin 0 0. Fx is equal to x is a line. Now let us see this example. Let f is from R to R be a linear function defined by fx is x plus 3. Find the x-intercept, y-intercept and graph of the function. As we have seen before in the previous presentations, for this function fx is equal to x plus 3, to find the x-intercept, we have to put y equal to 0. Y is 0 means fx is 0. Y is nothing but fx, the image. So if you put fx is 0, then you will get x plus 3 is 0. Fx is nothing but x plus 3. So x plus 3 is 0 implies x is equal to minus 3. Therefore, the y-intercept is 0. This we are getting x-intercept. Because we are putting y is 0, we are getting x is minus 3. Therefore, the x-intercept is minus 3, 0. So it intersects the x-axis at the point minus 3, 0. The next one, we want to find the y-intercept. To find y-intercept, we have to put x is 0. So if you put x is 0 in this equation, fx is equal to x plus 3. If you put x is 0, you will get f of 0 is equal to 3. This will be the y-intercept, y value when x is equal to 0. Therefore, the y-intercept is 3 and the point is 0, 3. So the 2 points we got. Since x-intercept is minus 3, the point it passes through is minus 3, 0. Since y-intercept is 3, it passes through the point 0, 3. So this is the line which passes through minus 3, 0 and 0, 3. So we find the intercepts and thereafter we find the curve passing through those 2 points, which is a straight line. Let us take another example. Let f be a function from R to R defined by fx is equal to x minus 0.5. Find x-intercept, y-intercept and the graph of the function. Always the linear function represents a straight line and we have to find x-intercept and y-intercept. So the given equation is fx is x minus 0.5. So to find x-intercept, you have to put y is 0. Y is nothing but fx. Fx is 0. If we put fx is 0, x minus 0.5 is 0 is equal to 0. That implies x is equal to 0.5. Therefore, the x-intercept is this point, x value 0.5 and y value will be 0. So this is the x-intercept. And to find the y-intercept, you have to put x is 0. If we put x is 0, y value will be minus 0.5. Therefore, the y-intercept, we are getting minus 0.5 by putting x is 0. So the corresponding point on the curve is 0, minus 0.5. So the straight line passes through the points 0.5, 0 and 0 minus 0.5. And here we have a remark that the graph of fx is equal to x plus a is obtained by shifting the curve fx is equal to x a units to the left if a greater than 0 and minus a units to the right if a less than 0. This is very important. This is called translation. If we want to get fx is equal to x plus a, first we write fx is equal to x and then we shift either towards left or towards right. If we have x plus a, we have to shift to the left a units. If we have x minus a, we have to shift the curve fx is equal to x to the right a units. So let us see the example. Fx is equal to x plus 2 is given. So to write this curve, first we write fx is equal to x. This is the curve fx is equal to x which passes through the origin. Fx is equal to x is a curve, it is a straight line passing through the origin. When x is 0, y is 0. Fx is nothing but y. Y also will be 0. Therefore, fx is equal to x plus 2. How we get fx is equal to x plus 2? Just shift the curve fx is equal to x 2 units, because plus is there. Whenever there is plus, we have to shift to the left. How many units? 2 units to the left. So we are shifting this curve 2 units to the left, and we got this one. This is fx is equal to x plus 2, where it passes through the point minus 2 comma 0. And if you want fx is equal to x minus 3, this is minus is here. When there is minus, we have to shift this curve fx is equal to x to the right 3 units here. So fx is equal to x curve, this curve, we have to shift 3 units to the right to get fx is equal to x minus 3. So this is the curve fx is equal to x minus 3, which passes through the point 3, 0. So together, how you can summarize? Whenever we have this fx is equal to x, by shifting to the right or shifting to the left, we can find the equation of fx is equal to x plus a. A is any constant here. If there is plus a, where a is positive, like fx is equal to x plus 2, we have to shift this line to the left 2 units. If we have fx is equal to x minus 3, like here, we have to shift this curve 3 units to the right. So this is the remark. It is about obtaining the function by shifting to the right or to the left. The graph of the line, graph of fx is equal to x plus a, which is a straight line. And we have one more example. F is a linear function defined by fx is minus 2x plus 7. Finding x-intercept, y-intercept and the graph of the function. First we find x-intercept by putting y is 0. Y means fx. If we put fx is 0 here, we'll get minus 2x plus 7 is 0. If we solve, we'll get x is 3.5. Therefore the x-intercept is 3.50. X value 3.5, y is 0. Similarly, if we put x is 0 in this equation, if we put x is 0, y, that is f of 0, will be equal to 7. If we put x is 0, y value will be 7. Therefore, the y-intercept is 0, 7. Therefore, the line passes through the point 3.50 and 0, 7. This is the graph of the linear function. And we have another example. G is a function from R to R defined by gx is equal to 4x plus 12. Again, the same way we find x-intercept and y-intercept. To find x-intercept, we put y is 0. Y is nothing but gx. The image always we denoted by y. So y is 0 means 4x plus 12 is 0. So 4x is equal to minus 12. So if we divide by 4, x is equal to minus 3. Therefore, by putting y is 0, we obtain the x-intercept, x is equal to minus 3. So the curve passes through the point minus 3, 0. And the next one, by putting x is 0, we will get the y-intercept. If we put x is 0 here, 4 times 0 plus 12, that is 12. So y value will be 12 when x is 0. So the point where it intersects y-axis is 0, 12. Therefore, the line passes through the point minus 3, 0 and 0, 12. This is how you find the equation of the line, the graph of the line in the xy plane. And these are the two problems on the exercise where fx is given. You have to find x-intercept and y-intercept and write the graph of the function f. For both, you have to write the graph of the functions. So this is the end of the presentation.